So welcome back students. We are discussing queue implementation using linked list. So in the previous video we saw that the queue implementation using linked list looked like this. We have a linked list. Linked list means there are nodes which are interconnected. So this is first node. In, it is storing the address of the next node, right? And then this is the third node, right? And if there is no next node, this is a linked list, right? In linked list we have nodes. This is the first node, second node, third node. In node I have two things. One is two parts. One is data part and other is the pointer part. In this pointer I'll store the address of next node in the memory. This is the next node, not in memory, in the linked list. This is the next node in the linked list, so I will store memory address of this node in here. That's why this arrow indicates that I am storing address of this node here. Similarly, here also I am storing address of next node, and there is no next node here. That's why this pointer is null. Right? Now this is a linked list. Now I want to use two pointers. One is F and other is R. F will be pointing to the oldest node by time of insertion in this linked list. So let's say this is the oldest node by time of insertion. So F will point here. And I have another pointer called as R, which will point to the uh, latest node or the youngest node by time of insertion in the queue. Right? So this is the, let's say this is data is 20 here, 30. Right? So these F and R are similar to the front and rear variables which we had while we implemented queue using arrays, right? So queue using arrays, if you remember, in queue using arrays we had this data array, this F and this R. So if this is the queue 10, 20, 30, 40, 0, 1, 2, 3, 4, so F was 0 and R was 3. So this F was storing here the array indices, right? The location of the element which has come in first in the queue will be stored in front, and rear will store the location of the element or index of the array where the element which has come in most recently is stored. That index we are storing in R. So R and F are storing these indices which are integers. So these are integer variables here. But here this F and R are not integer variables. They are pointers, actual pointers, which are pointing to the nodes of the linked list. Nodes of the linked list. F will point to the oldest node by time of insertion, right, or the node which has come in first, and R will point to the node which has come in or inserted last. And this complete structure is called as queue. This is queue, right? So here if you observe, there are two things. One is this linked list, right, and then this is this variable. This variable I'll call as queue, and inside this queue variable I have two pointers. One is F and other is R, right? F and R. So how to create those structures here? We have seen in the last video we can create this structure by using struct node. I'll rewrite here struct node of the linked list. Inside that we have data, int data, and then this next pointer which is inside this structure, right? So the type of this pointer is, it's pointing to the node, struct node. Again, this is a struct node. The type of this pointer is struct node, and as it is pointing to the next node in the linked list, it is next. Name of that pointer is next we are using. So another structure I will use to create this type of variable, these types of variable queue. Inside queue I have two pointers, right? So queue can be created by using structure, right? So the structure for creating queue type variables like queue is like this: struct queue. Inside that I have two pointers. One is F and R. And what is the type of F? F type is, F is pointing to a node, right? Node, that is struct node. That's why F's type is struct node. R is also pointing to a node. That's why the type of R is also struct node. So struct node star F comma star R. So these two structures we'll be using to create queue or to implement queue using linked list. Now let us see. Let us say we wrote these structures, and inside main function, what will I declare first, right? Or if I want to create the queue, what should I declare, right? When the queue is empty, there will be no node in the linked list. This will be empty, right? There is nothing here, but this will be there. This will be there. This queue variable will be there, right? Because though the queue is empty, if the queue is empty, f will not point to anyone. F will be null or will be null. So the situations are, if you see here, when the queue is empty, empty queue, it will look like this. I have this f and r. So if the queue is empty, f will be null. It's not pointing to any node. R is also null because there is nothing in the queue. That's what, right? If I insert the first node in the queue, I'll show you the situations. F and r. F is here, R is here. When I insert the first node, let's say I insert this node in the linked list, 10. This is the only node in the linked list. So f will point to this node and r will also point to this node because this is the only node in the linked list, right? Let's see one more situation where I will insert one more node in the linked list. So this is our f. In fact, this array, this structure object, I'm going to call as q. Right? And these nodes are created dynamically. These nodes are created dynamically by using malloc, dynamic memory allocation. So when I insert one more, so this f will point to this old node 10, and I'll insert a new node here, right, 20. So this next pointer will point to this newly created node, and this r will now point to this node. So this is the queue when we have two nodes. This is the queue when we have one node. This is the queue when we have no node inside the queue. And if you insert one more node, f will remain here, r will point to the newly created node, right? I'll insert a node here. I'll create the link between these two nodes, right? There is no next node. Data is 30, so r will no more point here, but r will point here, right? So that is how we'll insert the nodes inside queue, and that is how f and r will the values of f and r will change. Okay. Now, let's write the code for this. Let's write the code for this here. Let's say we created this queue. How will I create this queue? Our queue here is initially only this structure object queue. So that's what I will declare in order to create the queue using pointers, a queue using linked list. So how will I declare this queue? How will I create this queue? What is the type of this queue? I am using this structure. This structure I am using to create such variables, right? So struct queue. I'll write struct queue. For creating this, I'll write struct queue, capital Q. Now this queue is the variable of this type. When I declare this queue, exactly I'll have is this thing, f r, right? What is the value of f and what is the value of r? That we don't know. There might be some garbage there, right? We have not set any value for f and r, right? So that is what you will have when queue is created. Now, as I have just now created queue, there is no node inside the queue, so f should be null and r should be null. That I should do. I should set f to null and r to null. So that is called as initialization of the queue. If you remember, queue using arrays, we said f is equal to 0 and f equal to -1, r equal to -1 when queue was empty. So that was initialization of the queue in arrays. So here I will set f to null and r to null. So that is called as initialization of the queue, right? So I created this variable. Now I should initialize this. Initialize this means I should set this f to null and r to null. How will I do that? I can call init function or initialize function. Initialize. I'll pass the address of this queue, right? Initialize and queue, right? Initialize and queue. I'm sorry for this. So I'm calling this initialize function. To this initialize function, I'm calling the address of this queue. So let's write initialize. So void initialize. Let me use another color here. Void initialize as you are passing the address of this q type variable, right? What is the type of q? Struct q. You are passing address, that's why you need a pointer here. Let's call pointer as p. And what is the type of this pointer? What type of address we are getting in p? We are getting address of struct q type pointer, struct q type variable. That's why the type of p should be struct q. Struct q. In short, when I pass this address of q to initialize, right? So that q's address will be stored in p, or p is pointing to this q. P is pointing to this q like this, right? Then I want to access the contents of the structure by using this p, right? So again, the concept, this q is a structure, p is a pointer. So if I want to access f, I should say p arrow f. I'll say p arrow f equal to null, right? Similarly, I want to set, so this will set this f to null, right? And I want to set r to null, so I should say p arrow r equal to null, right? So this will set this to null, right? So that is the initialization of the queue, right? Okay, so I hope you understood this. So we'll see the remaining functions in the next video. I hope you are getting the things right. So see you there. Thank you.